Hello everyone and welcome to a new video. This video is going to be about magnets. First of all, let's start with introducing what is a magnet. Actually, a magnet is a material that can attract iron and some other metals. This is a shape or one of the shapes of magnets. As you can see, every magnet has something called a north pole and a south pole, and it's indicated with a letter N or S. N is for the north pole and S is for the south pole. Magnetic interactions, poles can attract and repel each other just like electric charges. So if I get a north pole close to a south pole, they will simply attract. But if I get a south pole close to a south pole or a north pole close to a north pole, they will simply repel. Now, what's nice about magnets, if you cut a magnet in half, say, let's look at this magnet. If I cut it in half, I won't have a north pole and a south pole separated. I will get two new magnets, each magnet with a north pole and a south pole. And if I divide it again, the same will happen again. Now, when it comes to magnetism, there are three types of materials. The first type is the magnets themselves, materials that are always magnetic, and they come in many shapes. There's the bar magnet, there's the horseshoe magnet, etc. Second of all, we have ferromagnetic materials. Now, ferromagnetic materials are materials that exhibit magnetic effects, but only in the presence of magnets. So they can be attracted to magnets, but they are not magnets. And finally, there are non-magnetic materials. These materials are not affected by magnets and they do not interact with magnets. Now, if I have an unmagnetized piece of iron, I can magnetize it. This is called magnetization. It can be done simply by applying two magnets on each side of, say, a ferromagnetic material such as an iron bar. Then I will apply heat on this piece of metal and I will start tapping on this piece of metal. So finally, this material will be transformed into a magnet. Now that's all what we have to say about magnets. Let's look at some quick questions. Question number one, if each side of a metal bar is attracted to the north pole and the south pole of a permanent magnet, it can be correctly concluded that the bar is, first of all, a permanent magnet with two north poles. We can exclude this answer directly because no magnet can have two north poles. And a permanent magnet with two south poles, the same goes here. There's no magnet with two south poles. Part C, it's a permanent magnet with a north and a south pole, or it's a material made of a substance that can be magnetized. Okay, let's imagine this. Now we have a south pole and a north pole. It's saying that if I bring a piece of metal, it's being attracted when I get it close to the north pole, and the same piece of metal, it's being attracted when I bring it close to the south pole. So this means that this is simply a piece of metal that can be attracted to either the north or the south pole, because if it was a magnet, it would have repelled if this was a south pole. But it says here that it's being attracted whether I bring it to any side of the magnet. So the answer is clearly D. Now, which of the following describes the effect of poles of a bar magnet on iron fillings? When each of the poles are brought near to the fillings, what happens at the north pole and what happens at the south pole? Actually, it's pretty easy and direct. It will be attracted on both cases because metal materials are attracted to either the north pole or the south pole. They do not repel, such as north pole to a north pole or south pole to a south pole. So in both cases, they will be attracted. So it's a pretty easy lesson. It's just an introduction about this chapter. We introduced what magnets are. I hope to see you in the next videos, so stay tuned.